Wow, everybody got quiet as soon as I turned the lights off. It's like at the theater, like it's like all this anticipation about what's going to happen tonight. It is like the eclipse, except it didn't get cooler this time. So, okay. All right. Is that better? That's not better. That's better. All right, I'm getting the thumbs up. Doug on Zoom, is that good? I got the thumbs up from the back and people can see the PowerPoint, so we're good to go? Okay, we're trying out a new gadget tonight. This camera should follow me so people on Zoom can see me, but oh, it did follow me. So welcome everybody to the April meeting of the Hamilton Amateur Astronomers. Thank you all for coming tonight. We've got like a big crowd. I don't know how many people are on Zoom, but we've got a big crowd in the room. So welcome to everyone. Is there anyone who's here for the first time tonight? Oh, yes, some of you are definitely here for the first time tonight, including our guest speaker and his wife. So thank you all for coming, and I hope you feel welcome. Make sure at some point in time tonight you speak to me and tell me about what brought you out tonight. I'd love to hear that. So my name is Sue McLaughlin, and I am the chair of the Hamilton Amateur Astronomers. And if I seem a little discombobulated tonight, it's because I've got many kilometers of eclipse chasing in my back pocket. So I still feel like I've been hit by a truck, but that's okay. So tonight, what's on our agenda tonight? Nothing. Ah, there we go. All right. So we're going to start off with some announcements. Then we have an awesome guest speaker. I saw our guest speaker in the summer at Starfest, and I was like, oh, he's got to come talk to us. I'm going to go talk to him. We're going to have our break, our door prizes, and then we're going to have some time to share some eclipse stories afterwards. Many of you have sent pictures to Matthew. He's put together a slideshow of eclipse pictures that have been taken. We won't have a regular sky this month so that we can all debrief and share our adventures with the eclipse, which has been awesome for some people, not so awesome for others, depending on the sky, but we'll get a chance to share that later. So our announcements. Last month, we had $90.25 and 1 can of soup donated to the food bank. I wasn't sure about the 1 can of soup, but that's all there was. So I was like, oh, okay, we got 1 can of soup. So we'll donate that. The Event Horizon newsletter deadline is Friday, April 26th before midnight. And again, if you want to write an article about your eclipse adventures, I'm sure Bob would love to put that in the newsletter. So think about doing that. Some things in the distance are the HAA picnic and the public Perseid nights. In the past, the HAA has hosted a picnic for members and their guests at the Binbrook Conservation Area. There was no charge for us to use one of their pavilions and no charge for us to get into the park earlier in the day. The potluck picnic will be a bring your own drinks and bring something to share. Details yet? I haven't got that far yet, but I'm just letting you know that August the 10th will be our picnic, weather permitting. That is also the weekend of the Perseids. The Perseids meteor shower doesn't peak until a couple of nights later. But on Saturday, August the 10th, we're going to, Binbrook opens the park to the public. The public comes to the park to view the meteors, and we can have anywhere between 700 and 1,000 or more people who come to the park that evening to look at the night sky. Most of them bring blankets and lawn chairs, and they sit on the lawn and they look. We have telescopes set up so that they can have a peek at the night sky. Jim sometimes brings his meteors, which is a big hit with the, oh, we'll bring the meteors. Joanne will bring the meteors. So it's their big hit with the kids and the families. We will need volunteers for that. So if you come to the picnic, you're going to stay and help us afterwards. Or you can just come afterwards. We need parking marshals, we need direction marshals, we need people to bring scopes, etc. And as I said, this is a long way off, but I'm just letting you know now that this is something, because summer gets really busy really quickly, and I'll have more information out for you in the next couple of meetings and also in the newsletter. The other big event that's coming up again at the end of the summer is our third annual HAA Dark Sky Star Party. I can't believe it's our third. It feels like we just did our first one. This one is hosted at Andromeda Meadow, which belongs to Dave Skelton, who lives in Owen Sound. This is a dry camping weekend. There's no hookups, there's no water, there's no electricity. You're out basically in a field surrounded by forest on the edge of the Niagara Escarpment to the east of Wyerton. It has excellent dark skies. We get together on Saturday night and have a buffet dinner, usually Chinese food. We camp there. There's lots of spots to stay nearby. And because this is the long weekend of September, we've extended it a little bit longer because the porta potty people will not come and pick up on Labor Day. So we can stay a little bit longer because those are the only facilities that are on site. Registration for this opens at 10 o'clock on April 27th. And if you are interested in going, especially if you have a trailer, reserve your site with me like right away, Tom. I'm just pointing at you back there. Get in there right away. He was upset because he wasn't the first person to register last year. Doug was because he had to test the software. So it's a great, great time. Those of you who have gone can attest to that. So there's a picture of the happy smiling faces that are there. And this is a rain or shine event, we hope. Shine more than rain. So there's just our upcoming events. Our next speaker in May is Dr. Chris Gillings. He is from Snow Lab. And Snow Lab is Canada's deep underground research lab located in the Vales Crichton mine near Sudbury, Ontario. The science program at Snow Lab focuses on astroparticle physics, specifically neutrino and dark matter studies. Dr. Gillings will come to speak to us about how we look for dark matter and why we think we understand the history of the universe, but only if 80% of the matter is invisible. And I can't wait to hear that. It sounds very intriguing. And then we've got our Binbrook openings, hopefully weather permitting. Paula, I'm not sure. Jeff, are you opening tomorrow night? Okay, so you'll let me know in the morning? Okay, not a problem. So an email. Yeah, if it's really windy, it's not good for telescopes. And it is really windy. So let me know in the morning. So it may be open, it may not. And there's the other things that I have talked about. So tonight we have a very special guest speaker, and he is here in person, which is a treat for us. Perry Edmundson is a lifelong space enthusiast and avid supporter of manned and robotic space explorations. He has over 25 years of experience in the Canadian space industry, working on commercial and government space projects in various technical and management roles. He obtained a bachelor's degree in aerospace engineering from Carleton University in 1996, followed by a master's degree in astronautical engineering from the Viterbi. I said that right? Viterbi School of Engineering at the University of Southern California in Los Angeles in 2011. And he is a licensed professional engineer. He is an alumnus of the International Space University's Space Studies program in 2005. And for the past 5 years as program manager at Canadensys, he has managed numerous space mission proposals, concept studies, and technology development projects of the Canadian Space Agency, primarily related to lunar rovers. He is currently managing the development of CSA's Lunar Rover mission at Canadensys, and I hope it has a better name by now. Well, we'll see. So please give a warm welcome to Perry Edmundson. And you're just going to give us a minute to switch over technology here.
Got it on. Oh, good. Great. We got one more.
Yeah, I know.
Okay, excellent. And this is the clicker, right? All right. So it's just the one that says HAA there. All right. And presentation mode. Once I put it in presentation mode, you could share probably that, right? Let's go. Yep. Yeah. Excellent. All right. Well, good evening, everybody. I'm happy to be here. So thanks very much, Sue, for the invitation. Happy to be here tonight to give you a little bit of background on kind of a neat project that we're working on that I would say most people in Canada and even people in sort of areas that are kind of tangentially related to the space business, like astronomy, very few even in those circles know about this. So hopefully after tonight, you'll know a little bit more and you'll be able to kind of spread the word and some of the excitement that we feel while we're working on this. So I'm going to talk tonight about Canada's Lunar Rover mission. So before I get too far into it, did anybody know Canada was developing a lunar rover besides maybe Sue, because she heard this talk before? Okay, so I saw a few hands go up, so that's good. Usually when I ask that question in a group, the number of people that respond and say they've heard about this is like less than 10%. So and historically in Canada, those of us that are involved in this kind of work and the space agency themselves, we haven't done a great job of promoting the work that we're doing. And as a result, a lot of Canadians don't really know what's going on. So this is really important for me to have an opportunity to share this. So thanks again for the opportunity. All right. So before I get too far, today is April 12th, which is the anniversary of the first human spaceflight back in 1961. Gentleman that looked a little bit like this guy named Yuri Gagarin. It's the first human in space. And in more recent years, April 12th has become known as Yuri's Night. There are worldwide space parties that happen on this day every year, commemorating the first human spaceflight. So happy Yuri's Night. Is anybody going to like a wild space party after this? Maybe this is it. Is this it? All right. Fantastic. All right. Yeah, is there any way we can drag that toolbar out of the way? Maybe. Ah, you got it. Very good. Thank you. Okay, so you may have heard that Canada is involved in this international effort to return to the moon. A few years ago, Canada announced an investment in this program, and Canada is going to be providing a new Canadarm. I'm sure most people in this room have heard of Canadarm. There are two of them that have been developed. First one was for the space shuttle back in the 1980s. Then Canadarm2 was developed for the International Space Station, which is in orbit around the Earth, still in operation today, and was really instrumental in building the International Space Station. It's essentially the construction crane that moved everything around and connected all the modules together, and is still used today to service the space station on a regular basis. So Canadarm3 will be an advanced version of Canadarm, and it will be installed on a space station that will be in orbit around the moon called Lunar Gateway. Lunar Gateway will be primarily the United States that will build the actual station itself, but there will be, similar to the International Space Station, there will be international contributions, and Canada's contribution will be Canadarm3. And so the way that works is, as a country or a space agency, if you contribute something significant to a mission like that, in return, you get to fly some of your astronauts. And so you've probably heard that on the next flight of NASA's Space Launch System, which is a mission called Artemis 2, Canadian astronaut Jeremy Hansen will be flying. And that will be the first mission on the Space Launch System to actually orbit the moon and come back. They won't be landing on the moon on that mission. That won't happen until the next one, Artemis 3, a couple of years after that. But it's still a pretty neat thing for Jeremy. He'll be the first Canadian to ever leave low Earth orbit. And he'll be orbiting the moon, and so that'll be pretty exciting. Looking like that mission is probably going to happen in late 2025 now, maybe. It had originally been scheduled for late 2024. Late last year, it got delayed by about a year. So funny thing about launch dates, they continually move to the right. And it's kind of funny how it works, because, you know, when you're several years out from the mission, it moves almost as far to the right as the calendar moves forward. So you seem to never get closer to the actual launch date, but you do move a little bit closer to it. And then as you get to within kind of a year or so, it doesn't, the rate that it keeps slipping reduces. So you do eventually get closer to the date, and there does come a time when you actually do have a launch. It's just usually much later than you ever expected it would be. So as you can understand, all of the equipment being developed, all the vehicles, the support systems, the life support systems, especially in a manned spacecraft, are incredibly complex. Usually the effort required to develop them and test them and prove them safe is underestimated, and the cost as well. So things just take longer than we expect when we start out on a project. And that's not unlike our Lunar Rover mission that we're working on. Anyway, so in addition to Canadarm3 and our astronauts being involved in the lunar program, the Canadian Space Agency a few years ago set up another program along with those called the Lunar Exploration Accelerator Program, conveniently called LEAP for short, being, you know, going back to the moon, kind of appropriate. So this program was especially targeted at small and medium-sized companies to help them sort of get into the lunar game, if you will, by developing new technologies like science instruments, and in our case, a rover. And so the Lunar Rover mission falls under this Lunar Exploration Accelerator Program of the Canadian Space Agency. Should point that this way, probably. Uh-oh. Yeah, it was working. We need to just click on the screen once or something. Just to back. Oh, got the green light. Yeah. Just does not seem to want to. Okay, I can just use the keyboard. Oh, it won't even go there.
No.
Oh boy.
No,
It wouldn't.
it won't. It's frozen.
Oh, okay. Now let me try it now. No. Try the old Control Alt Delete.
Yes, because mine's running too in the background.
Totally. Technology is wonderful when it works. Okay, good. Yeah, we didn't have PowerPoint back then. Probably a good thing, right? Yeah. That's right. Okay. Yep, there it is. So just presentation. Okay, yeah, I can see if I can click through. Yeah. Okay, good. Great. Bus escape to show. Oh. It seems like as soon as you hide it.
As soon as we get rid of the balloon controls. Okay. All right.
Okay, yeah.
Go ahead.
Okay. Oh, okay. Yeah, didn't look like it. Okay, great. Thank you. All right. Sorry about that. We're back in business. All right. So Canada's Lunar Rover mission. So the plan is we're going to send a 35 kilogram rover. So not very big. It would easily fit on this table with a suite of scientific instruments. And we're going to send it to a landing site in the South Pole region of the moon. And it will be searching for frozen water in the lunar regolith, as well as other minerals. And launch is planned for no earlier than late 2026. Do you like that for a non-committal date? So remember what I said before, how launches keep sliding? Yeah. Don't start watching for this in late 2026. That's all I can say. Yeah, well, we'll do our best, but you know, some things are out of our control here. Yeah, so this is actually a collaborative mission between the Canadian Space Agency and NASA in the US. We are carrying a NASA science instrument on board the rover, along with some Canadian science instruments. And in exchange for that, NASA's giving us a ride to the moon. So pretty good trade, I'd say, really. So NASA has established a program in the US called Commercial Lunar Payload Services, or CLIPS for short. And it's a way for them to engage with the private sector in the US. There are a number of companies developing lunar landers, and NASA, rather than the old-fashioned way about, NASA would contract with somebody and then they would tell them exactly what to do and how to do it, and it would take a long time and cost a lot of money. So this is a different approach NASA's taking, and it's modeled a little bit on the approach they've taken in recent years with sending crew and cargo to the International Space Station. They pay for the ride. They pay a commercial provider for the ride. They don't tell them how to build their vehicle. There are certain requirements they have to meet, especially in the case of crew, they have to meet a lot of safety requirements. But other than that, they pay by the pound, essentially, to send cargo and crew. So it'll be the same for CLIPS. And there are a number of companies right now developing lunar landers in the United States. There have already been a couple of attempts at missions this year already. And those missions were originally planned for a few years ago, but they finally did get off the launch pad. There's a company called Astrobotic that launched a mission in January of this year. They unfortunately encountered some difficulties after launch, and their vehicle never managed to get out of Earth orbit. So it didn't even start its journey to the moon, unfortunately. They had a fuel leak on board the lander, and that was it. So that mission ended prematurely. Then last month, and I'll show you a photo in a few slides here, another company called Intuitive Machines launched a mission, and they did make it to the moon, and they actually successfully touched down on the moon. Our company was fortunate enough to have some cameras on board that lunar lander. The photo that I'll show you soon came from one of our cameras. The mission was mostly successful, I'll say. The lander ended up tipping over. And so it wasn't able to communicate quite as well with Earth as they had planned, because the antennas that were supposed to be above the surface of the moon were now laying on the surface of the moon. It also wasn't able to generate as much power as they had hoped. But they managed to get several days of operations out of it. And big thing is they learned how to actually fly a mission to the moon, which is pretty substantial. So yeah, exactly. Learn by your mistakes. So we will be on one of those CLIPS missions in the next few years. There are a number of more companies working on these missions, and they're already under contract to fly to the moon. So we're going to see probably 2 or 3 missions per year flying from the United States to the moon over the next 5 to 10 years, I guess. Those will all be unmanned missions. They're just sending experiments and smaller lunar landers to the moon with things like this on it. And it's all in preparation for returning astronauts to the surface of the moon. That is looking like it probably won't happen now until 2027 at the earliest. But we'll get there. All right. I don't think I need to tell this group too much about the moon. I think there's probably a lot of people here that know a lot about the moon. Some of you probably know more than I do about it. So obviously it's Earth's closest neighbor in the cosmos. Formed, they believe, scientists believe, formed in a collision between Earth and another Earth-sized object about 4.5 billion years ago, when the solar system was in its infancy and planets were just forming and kind of coalescing in their orbits around the sun. It was a bit chaotic back then. So the moon essentially is a piece, or was originally a piece of the Earth. 384,400 kilometers away in orbit around the Earth. And as we know, the moon orbits around the Earth once every 28 days. And interestingly, the moon also completes one full spin on its axis in that same 28 days. And so what that means is, and you can see it in this kind of image, this figure over here, from Earth, we always see the same side of the moon. We never see the other side. The other side is always facing away from the Earth. So when you look up in the night sky, you see the same side of the moon that humanity has seen as long as humanity has been in existence. But we do know what the other side of the moon looks like because we've sent spacecraft there and we've photographed the far side of the moon. And the image on the right here is a composite image of photographs taken of the far side of the moon. And you can see it does look a bit different than the near side. The near side has a lot more of these smooth kind of what look like seas or basins, whereas the far side of the moon is very much more kind of just pockmarked with tons more craters and things. So it has been exposed to more bombardments from asteroids and things. And so, yeah, as recently as just last August, there have been some photos of the far side of the moon taken. There was a Russian mission called Luna 25 that attempted to land on the far side of the moon. And it took this photo of an area called the Zeeman crater, which is kind of in the southern hemisphere of the far side of the moon. Took that photo on August 17th before it unfortunately crashed into the surface of the moon when it ran out of fuel. So that landing was not successful. So what's it like on the moon anyway? What would it be like to live on the moon? Very dusty. The lunar regolith, or what they call the soil, is it's like an extremely fine powder, almost like flour. But also the particles are very, very abrasive. So they tend to just foul up equipment, especially anything with moving joints. They just cover the astronauts' spacesuits and they just cannot clean it off. It just sticks like nothing you've ever seen. Yeah, so it's really annoying. Gets into everything. And it's also, inevitably when they're back inside their spacecraft and they're taking their spacesuits off, they end up breathing some of this stuff in and it causes respiratory problems. And yeah, it's just really nasty stuff. So that's one of the big challenges. Very low gravity. So 1/6 the gravity of the Earth. Great news is if you want to lose some weight, just go to the moon. If you weighed 60 kilograms on Earth, you'd only weigh 10 kilograms on the moon. And if you wanted to be a basketball player, you could jump really high on the moon too. That'd be kind of fun. When the sun is up, so because of the way that the moon completes one spin on its axis in the same 28 days that it takes to orbit the Earth, and the fact that the same side always faces the Earth, that means for half of its orbit, 14 days, the backside of the moon is facing the sun. So it's in the sun for 14 days straight. Gets really hot, over 110 degrees Celsius, so over the boiling point of water. And then the other 14 days, that side is in the dark. And the temperature plunges to below minus 200 Celsius. This is also because the moon doesn't have an atmosphere. There's no air. So on Earth, our atmosphere helps regulate the temperature. You don't have that there. So the combination of no atmosphere plus these long days and nights means you have these wild temperature extremes. That's a big challenge for designing something to survive on the moon as well. It's probably that is, if not our number one challenge that we're facing right now, it's really close. So why do we want to go to the moon anyway? Like, didn't we do that back in the 60s and 70s? Like, what's the big deal? Well, when the United States went to the moon in the late 60s and early 70s, it was really a flag planting exercise. It was a show of technological prowess and power that they were able to send astronauts there. The astronauts didn't stay very long. It was, a few hours or maybe a day or so, and then they came back on each of the missions. So there's a lot we still have to learn about the moon. There's a lot we don't know. And it helps us learn more about the Earth and our solar system in general, and kind of the Earth's place in the solar system. This time, the plan is to go in a much more sustainable way and to learn how to live there long term, so long duration. So setting up a human base there that can operate for weeks to months at a time and can be there long term and support multiple missions over multiple years. That will help us to learn how to live away from the Earth for long periods of time. And of course, once we learn how to do that, that will allow us then to explore even more distant places like Mars and other locations in the solar system. All right, come on. There we go. All right, so what is a rover anyway? So I'm not talking about that little cute guy up there. I'm talking about this guy on the bottom. Basically, a vehicle, could be crewed or uncrewed, kind of a general term, used for off-road, or in this case, off-planet exploration. Generally carries scientific instruments to collect information, take measurements, take images, collect data, and it allows for up-close scientific investigations. And in the case of an unmanned or robotic rover, means we can do experiments that we wouldn't necessarily otherwise be able to do unless we sent humans there. So it's a good way to kind of scout out somewhere in advance of sending a crew, learn as much about the region as you can, and about the challenges to supporting human life before you actually send a crew. All right, I'll give you a little bit of a walkthrough of our vehicle. So this is what it looks like. It's a four-wheel vehicle. As I said, it would easily fit on this card table here. So it's approximately 70 centimeters on a side roughly sort of cubic shape, except that the upper shell is tapered. So it's a little bit smaller at the top than it is at the bottom. The sides are on the top, first of all, is where we have a radiator to help us expel excess heat during the daytime. And when the vehicle is operating, the electronics and mechanisms inside generate waste heat. So that's how we get rid of it. There's some equipment inside the Rover that transports heat from the various parts up to the top, and then the radiator expels it. And the bottom is a sealed chassis to keep all that nasty lunar dust from getting inside and fouling up the instruments and the electronics. On that tapered upper shell, we have body-mounted solar arrays on all four sides. So that's how we power the vehicle, with solar power. And we have cells on all four sides so that regardless of which way we're driving or which way we're facing relative to the sun, we can generate power. So as I said, it's a four-wheel vehicle. It drives by skid steering. So for those of you who are familiar with a skid steer, maybe you've operated one, or a tank is kind of another analogy for this. The wheels themselves do not turn. They face only in one direction, and you steer by driving one side different from the other. So either you drive both sides in the same direction, but at two different speeds, and the vehicle will turn, or you drive one side forward and one side in reverse, and the vehicle spins in place, essentially. So that's how we drive. It's quite simple. The two wheels on one side of the vehicle are mounted on a central pivot. And let me see if I can get this laser pointer to work. In this central pivot is also a motor which drives a pair of wheels. So what you can't really see in this image is there's a kind of a transmission that runs from this central housing down to each wheel. You can see a little bit of it here. There's a chain drive mechanism in there which allows one central motor to drive two wheels. So there's two motors, one on either side. And this pivot also gives us a bit of kind of suspension capability so that the wheels are able to traverse uneven terrain. So they can climb over rocks and things like that, and allows kind of the rest of the vehicle to be a little more stationary. So it's a pretty capable system. This has been in development for a number of years. Canada kind of first started looking at lunar rovers way back in 2007, 2008. So the original vehicles that we developed were larger and just terrestrial prototypes to sort of learn how they work and how to drive them and things. And now we're down to this kind of much smaller size and much more space-like. And this will actually be a real space vehicle. So, but yeah, the drive system has been well proven. No, so good question. It will be controlled from Earth. It will not be fully autonomous. It will have some very limited, I hesitate to even call it autonomy. It will have some sensors that would, detect hazards and stop if it finds it's in an unsafe situation, basically, and then just phone home and wait for instructions. Something else is lots of cameras. So this thing's got a ton of cameras on board. Most of them are up here around kind of this crown, around the edges of the radiator. There's one also down here, which is a hazard avoidance camera that sort of looks right between the wheels in front of the rover to make sure you're not going to run into anything. These cameras are, the ones I'm showing here are what we call the guidance and navigation cameras, or the engineering cameras. I'll show you in a couple slides. There's also science cameras on board, but these are primarily used for navigation and situational awareness, to sort of look around and sort of see what the rover is, what the environment right around the rover looks like. All right. So also pretty advanced communication system that allows us to communicate with the rover from Earth, send commands, receive telemetry and scientific data back from the rover. And that's how we remotely control it. We can send drive commands, we can send imaging commands, we can request information back about the health of the various systems on board, and we can kind of keep tabs on how it's doing. So we have antennas on all four sides that allow us to send and receive signals. Initially, on the that first 14 days, or what we call the first lunar day, we will be able to communicate with the lander that gave us a ride to the moon, and that lander then will relay signals back to the Earth. But those landers, those initial landers that are being developed, will not have the capability to survive a lunar night. So when the sun goes down after the first 14 days and plunges the moon into darkness and cold, the lander will not survive. We are designing the rover, though, to actually survive that. So when the sun comes back up 14 days later and things finally warm up, if all goes well, we will continue our mission. And so we also have to have the capability, once that happens, to communicate direct with Earth, because that lander relay will no longer be functioning at that point. We have something called single fault tolerance on critical systems, and basically that just means either you have a backup way to do things if the primary way fails, or you have different systems that can accomplish the same thing. So you always have more than one way to accomplish a task, so that if you have a failure, you don't lose the mission. All right. Yeah, I think I've talked about most of what's on this slide. So, you know, we're sending this rover to take some close-up measurements in the region of the moon. I said it was the South Pole region. That's the same region where we intend to send astronauts when they eventually go back to the surface. There's lots of frozen water ice at the South Pole of the moon. That's the primary reason for the great interest in that area. Once we positively identify where the ice is and have technologies developed that can actually access that ice and convert it into potable water, breathable air, rocket fuel, that's all very useful for supporting a human settlement there, and for supporting other missions launching from the moon out into the solar system. So that's really the reason. All right, so I just said the South Pole region has lots of ice, and that's why we're going there. So I mentioned earlier the Intuitive Machines first mission that went to the moon. This was taken a day or two before they actually landed on the moon. So February the 22nd, 2024, this image, they were about 20 to 30 meters above the surface still at this point. So they were in their final descent to the surface, getting very close. And that image, as I mentioned, was taken by one of our cameras that was on board. So that was pretty cool. Many of those same cameras will be the ones that the rover is equipped with. Okay, so science instruments on board. Considering this is a pretty small little rover, we have quite a lot of scientific instruments on board. So what you don't see because they're inside the belly of the rover is a neutron and gamma ray spectrometer. That's for measuring, for measuring the sort of radiation environment that the rover will experience on the South Pole. Also, being able to detect neutrons is a way to identify where potential deposits of water ice are, just by the way the neutrons react with the ice. We also have some more science cameras on board, and some of the cameras that I said we were using for navigation, we are also going to use for science as kind of a secondary purpose. But then there are some dedicated science cameras as well. So we have a narrowband imager there up at the top, looking sort of diagonally down in front of the rover. We have another multispectral imager here, which is also looking down sort of more immediately in front of the rover. That can see in different spectral bands. So you can take images in different wavelengths of light, and that helps scientists identify different minerals in the soil. We have the US instrument that we are carrying called the Forge. It's a thermal imager, and it will be able to map the temperature distribution on the surface of the moon in unprecedented detail. So, and all of these instruments can kind of be used together. They sort of complement one another to allow us to achieve those scientific objectives that I talked about earlier on. All right, so how do we build a rover? It's a little bit like a rover is a little bit like a remote control car. So many of you, I'm sure, have played with remote control cars in the past. And the main parts of the rover are, first of all, the structure that kind of holds everything together, motors to make it move, wheels to make it roll, and interestingly, the wheels will not be covered in rubber tires, because rubber would not do very well on in the environment that the rover will be in on the moon. The temperature extremes, no atmosphere, and abrasive regolith would destroy rubber immediately. So no rubber. I'll talk a little bit more about the wheels coming up. Cameras, as we've said, it will let the operator see essentially what the rover is seeing and in the vicinity right around the rover, and will help to help the remote operators to decide what path to take. Communications for sending and receiving the signals. Computers, lots of computers, hardware and software to make everything work together. And of course, electrical power to power everything. Here's a screen on the right-hand side here that shows the user interface, or kind of an earlier version of the user interface that we developed for remotely controlling the rover. You can see kind of a top view of the rover there on the bottom. It shows different bits of information about all the different systems on the rover, to sort of let us know how the rover's doing and help us as we decide which commands to send, and it shows us what data we're getting back. So that's kind of our diagnostic screen, if you will, for the rover. All right, so manufacturing rover components. We're looking for things that are very lightweight, yet very strong and stiff. And so generally, we use materials like aluminum and titanium. Those are both very common in space flight applications. High strength, low mass. Increasingly, carbon fiber composites are also being used, again, for their very, very lightweight. They can be somewhat susceptible to especially low temperature. So we have to be a little bit careful there. Specialized manufacturing methods, of course, conventional machining, mills, lathes, that kind of thing. Increasingly, we're seeing the use of 3D printing in space applications. And this is not your desktop hobby grade 3D printer that prints out of PLA material or something like that. We actually can print in metal now, which is pretty cool. Aluminum and titanium in particular. So it starts from an aluminum or titanium powder and it essentially fuses it layer by layer and builds up a part. It's quite remarkable. I think I see a question at the back there. Liquid titanium. For manufacturing specifically, I'm not familiar with an application that I don't think I've seen it. That doesn't mean it doesn't exist. I'm sure it probably does. The ones that I have more experience with are the powders that they kind of laser fuse together. Okay. Okay. All right. Cool. Okay. Yeah. Interesting. I'm not sure if that's being used in space applications currently, but it may well be. Yeah, so it's a pretty some of these parts get pretty intricate. So you can see here up on the top right of the screen, one of the wheels. So I said no rubber tires. That's a completely 100% metal wheel. But the feature that makes it kind of interesting is it's not rigid. It actually does have flexibility, a little bit like a pneumatic rubber tire. These spokes are flexible. These individual traction plates can each move and flex relative to one another. So it does give you some compliance as you drive over uneven terrain. So that's pretty helpful. All right. So mobility, I said we've been working on Rover mobility systems for many years. We're up to about 9 generations now of prototypes. So this is probably the part of the Rover that has had the most development. That doesn't mean we know everything yet, but we're pretty comfortable with this. Locomotion mechanisms that have some ability to tolerate faults as well and continue moving. Seals that keep the dust out of the moving parts. And also can survive these extreme cold cryogenic temperatures. And we've done numerous tests in specialized test facilities called thermal vacuum or TVAC chambers, where we've exposed these things down to temperatures as cold as 30 degrees Kelvin, so 30 degrees above absolute zero. That's about minus 240 degrees Celsius, for those of you who are keeping track. And wheel designs, we've done a number of wheel designs scaled right from our current design, which is about 24 centimeters, all the way up to we've done wheels almost a meter in diameter for larger vehicles and done some pretty extensive durability tests on wheels like that. Okay, surviving the night. So I said this is probably our #1 challenge. It's very hard. This is very, very difficult. And typically the way this has been done is with nuclear power systems. So most vehicles that have ever had to survive cold temperatures like this have some kind of nuclear power source on board to provide not only electrical power, but also heat. We do not have any nuclear power sources on board, so we have to find another way to do this. And it's kind of a 3-pronged approach. First of all, you select components that can actually survive being exposed to those extreme cold temperatures. We find those by doing lots of testing, and then sort of taking the ones that survived and say, okay, we're going to use those. That doesn't work for everything. In particular, batteries do not do well at all when they're exposed to extreme cold. Any of you who drive an electric vehicle might know that you don't get very good range when it's very cold in the winter. And that's because battery capacity drops significantly with temperature. Below a certain point, you cannot even charge the battery when it's below about -20 Celsius or so. So we have to isolate some of these components and keep them within a much more comfortable temperature range. And the battery is the big one for doing that. You can see this diagram on the bottom of the slide, where we have this region called the warm box. That's where we house the most sensitive components, including the battery. And we design the support structure such that it is thermally isolated from the rest of the surrounding structure. So even when the rest of the surrounding structure gets very cold, as the temperature drops, when the sun goes down, we can keep that region in the middle of the vehicle inside isolated, and it retains heat for much longer than the rest of the vehicle. And so by supplying only a very, very, very small amount of heater power through the full 14-day lunar night, we can keep that region warmer than the rest of the vehicle. And so those most sensitive components, we can keep them alive. We're talking like a watt of heater power, but over 14 days, that's a fair bit of energy still. And that drives the size of your battery. And the battery is the largest and heaviest component by far in the rover. It's approximately 20% of the total mass of the rover is just the battery. So we don't want it to be any bigger than we absolutely have to make it. Why are we not using a nuclear source? Using nuclear sources comes with a lot of logistical complications. It's something that only a few countries have ever done in terms of sending nuclear devices into space. The US and the Soviets have done it, obviously. Canada has never done that. We've never actually sent a nuclear device into space. And so the thinking was, right from kind of the outset of the program, let's find another way because it's just too difficult. Yeah, and costly as well. And yeah, there's an element of there's safety considerations too. So yeah, the paperwork would be horrendous. I don't even want to think about it. I think we got a microphone for, yeah. Yeah, maybe that's easier. If you can just remember your questions to the end. Yeah. All right. Okay, so I talked about the cameras being used for guidance, navigation, and control. The cameras are certainly the primary sensors for doing that. We have a few other neat things on board. We have a it's essentially a very simplified LiDAR instrument. So on the front of the rover in the center, on the diagram that I showed earlier, you won't see it here, but we have a sensor which can generate a three-dimensional point cloud of data, basically. So up here on the top left of the screen, you can see an example of what that looks like. And so, and here as well, next to it, to the right. So you can kind of get a sense for, in 3 dimensions, what the terrain in front of you looks like. One thing about the environment on the moon that we haven't talked about is the lighting is incredibly harsh. That's another thing when you don't have an atmosphere to sort of soften the sun. It's extremely harsh. And so you can see some examples here, like this image on the top right on the slide here, where we're doing testing with harsh lighting in a simulated lunar terrain. It's a glorified sandbox, really, but it's big. It's like 60 feet by 60 feet, so it's kind of fun to play in. We have a solar simulator. It's basically a very, very bright light source close to the ground, because at the South Pole, the sun will only ever be a couple of degrees above the horizon. So all the sun, instead of coming down from above, it comes at you straight in your eyes, like when you're driving home at sunset during the winter, the short days in the winter. So you know how hard that is to drive. That's what we're going to be facing, either driving straight into it or driving straight away from it with long shadows, or driving kind of with it coming side on, generating long shadows sideways. So it makes judging the terrain very difficult, because it's hard to tell what's a shadow and what's an actual, like a rock or a hole, crater. Very, very challenging. So this 3D sensor helps us to, gives us another tool to use for doing that. We do have some lights on board, probably on 3 sides is what it's looking like right now, front and the 2 sides. Probably won't have one on the back. But we can kind of illuminate the area around us if we happen to drive into a shadow. And we actually plan to drive into shadows, because shadowed regions on the moon are where we are most likely to find frozen water deposits. And in particular, there are special shadowed areas of the moon that we call permanently shadowed regions. And these are just because of the local terrain, and especially at the South Pole, when the sun angle is just very sort of glancing as opposed to direct on normal to the surface. You can get regions, say at the bottom of a crater, where the sun never shines. And so those are the areas scientists are most interested in for exploring for frozen water deposits, because they never warm up. And so any water that did at some point get deposited on the moon, say it was carried there by a comet or an asteroid or something, that's where they expect those water deposits would eventually settle. So we're actually gonna drive into some of those and explore and take some measurements, but we'll need some local illumination to help us do that. All right, testing the rover. Obviously, you have to make sure this thing is going to work before you send it, before you strap it to the rocket and wave goodbye, because once it's gone, you're not going there to fix it if it's broken. So we have to make sure it's going to work. So we do this by building several test models. We test them using specialized equipment that can simulate the environment that the rover is going to experience during both its launch and flight to the moon, as well as once it gets to the moon. So we use things like a vibration machine or a shaker. Here's a picture here to the right showing a telescope. I think this was the Canada's Most telescope, or perhaps NeoSat, strapped to a vibration table. The table simulates the frequencies and vibration levels that the rocket produces during the launch. So we can make sure the structure is capable of surviving that. Big sandbox, as I said earlier. Another image here on the bottom of the slide that shows a rover being tested in our big sandbox. This one happens to be in our facility in Stratford, Ontario. Thermal vacuum chamber we talked about briefly earlier. That's this device here on the far right. That simulates the vacuum and temperature extremes of space. So you basically suck all the air out of there, and then you can vary the temperature from extreme hot to extreme cold and test the system, see how it works. Lighting conditions, we can also simulate that. We do that in our lunar sandbox here. The one thing that's almost impossible to simulate is the moon's gravity. There's no moon room on Earth that you can go to and say, okay, turn off gravity. That's really, really hard to do. So we don't really have a good way to do that. We can build things like lightweight models, like say, build just the bottom part of the rover, take all the other equipment out, take the battery out so that it's much lighter, so that we can test how the mobility system works. Yeah, we have limited flexibility there. So anyway, that's probably the most difficult. Lots of analysis required. So I talked a little bit about the US companies that are developing commercial lunar landers. Here's a picture on the right of the slide here of Astrobotics. Peregrine lunar lander, they call it. That's their smaller lunar lander. They're also developing a larger lunar lander that they call Griffin. And one of Griffin's first missions, in fact, it's supposed to be later this year, is to carry a US rover called Viper, much bigger than ours, but that's the plan. Is they're sending a US rover as well. Similar region to the moon, South Pole. They'll be doing complementary investigations to what we're doing. Other countries are in on this game as well. Bottom image here, I believe, is the Chinese rover, U-22. China has so far sent 2 rovers to the moon over the last several years. First one didn't survive its first lunar night, so it had a short life. The second one did survive a number of lunar nights. I'm not sure if it's still operating, but that's been several years now. So most recently, India landed a lander with a rover on board. That was last year. And so this is really much an international endeavor. The image on the far right on this slide shows a spacecraft being encapsulated in the nose cone of a rocket prior to being hoisted up to the top of a rocket and launched. So the rover and the lunar lander are stacked together, and then they're stacked in the rocket. After the rocket launches, puts us in orbit, sends us toward the moon. The lunar lander spacecraft does what they call an orbit insertion maneuver so that it captures lunar orbit, starts orbiting the moon, and then gradually lowers its altitude down to the surface until it actually makes a pinpoint landing on the moon. So that's what Intuitive Machines did just back in February of this year. First commercial lunar landing that they accomplished, and the first US lunar landing in since the 70s. So quite an accomplishment, especially for a private company. All right. That's the end of my talk. I just want to acknowledge the support of the Canadian Space Agency, who are the funders of this activity for us. They're our customer, great team to work with. And we have a number of both academic and industrial partners as well, who have their logos on the bottom of the slide there. This is, you don't do this on your own. Space exploration is a cooperative, collaborative endeavor, an international endeavor. And this mission is no different. So we're very grateful for the long list of partners to help us with this.
Thank you. I have the feeling that there's quite a few questions, so I'm going to start here with Celia. Gravity.
Okay.
And now you said, because I thought, what's going to stop it flying all over?
Yeah. Yeah. 1/6 gravity. It's enough to hold things down, but barely on the moon. So yeah, you have to be very careful with how you maneuver so you don't topple over.
I'm interested in mechanics.
Okay.
So how do you control or mitigate the expansion contraction of all that material from one extreme to the other
Yeah.
and still make it work?
Yeah, thermal expansion is a challenge as well.
What would it be, like decimal 0.0001 or
So
10 to the 1?
it's very dependent upon which materials you choose. Some are better than others. That's unfortunately one thing about aluminum that's not great, is its thermal expansion coefficient is relatively high compared to other materials. So we have to select materials for various components and design them in such a way that they don't cause, extreme stress. If you have one component that's rigidly attached to another component, but those two components are different materials with different expansion coefficients, that's a problem. So there are some ways you can design some flexibility in the mounting of components, flexure mounts and things like that, that can kind of take up some of those differences.
And
But
the second
that's-
question I have for you, you said there's lots of water. Is there a comparison you can give us to the water you expect to find in comparison to one of our Arctic regions?
Like in terms of quantity,
Quantity.
oh boy.
When you say there's a lot, there's a lot, and then there's.
Yeah,
the
I
Arctic
mean, I'd have to look up the quantity that they estimate is there, but it's sizable. Like it's, lakes to oceans worth of water. The big question is, in what form does that water exist? So they know there's water there because they've detected it from orbit. What we don't know, because we haven't been to the surface of the South Pole, we don't know how that water is distributed. So we don't know if it's in monolithic blocks of ice or if it's kind of mixed into the soil. And we also don't know if it's at the surface or if it's buried several meters below the surface. The reality is the answer is probably all of the above. But that's one of the key things that missions to the surface are going to be able to determine with better accuracy, is exactly what form this water takes, how prolific is it, and how easy is it to access. Yeah. With the mic there.
Hi there, Perry. My name's Jeff. Thank you for your presentation. Early on, one of the slides was about the launch and the fact that I think it said the launch won't happen before the end of 2026.
Yeah.
Strange coincidence. That's exactly what I tell my wife about the honey-do list.
When you're going to finish it by, right? Yeah.
But
No
what
earlier
are
than.
the roadblocks that are preventing it from happening sooner?
Yeah. So I mentioned that this is a collaboration between Canada and the US, right? And NASA has these commercial lunar payload services missions lined up for these commercial companies to take various instruments and rovers and things to the moon. And we're not good at predicting when launches are actually going to happen, because we're notoriously bad at predicting how long development of new technology for space is going to take. There are always unknown challenges that come up and bite you during these programs. There's risk inherent in these things, and we have to, sort of deal with those challenges as we encounter them, and things just end up taking longer than we thought. And when you have multiple parties involved, so in this case, not only do you have two space agencies involved, but you have that whole list of commercial companies as well, and many others. And we will not be the only thing on that mission, on that lunar lander riding to the moon. NASA will put a manifest together of multiple payloads. We call them payloads. It's the thing you pay to send, the load you pay to send, basically payload. But yeah, there'll be multiple instruments that all ride on the same lander. And so coordinating the schedules of all of those things when they're all going to be ready to go, it's a logistical challenge. Yeah. Yeah, to say the least.
Sure. Was just one more question. You mentioned, that you've done now 9 generations of development, which is
Yeah.
a phenomenal amount of research and testing.
Yeah.
Can you kind of compare and contrast to the way that SpaceX develops things, which is to blow up rockets and launch pads and figure it out afterwards?
Yeah. Yeah. That's really a new paradigm that SpaceX has created. Certainly breaks with the tradition of the space industry previously, which was analyze it to death and only build it when you're sure, and only attempt to launch when you're really, really sure it's going to work. And even then, usually, the first launch of a brand new vehicle is still rarely 100% successful. Yeah, SpaceX has really taken a different approach and just said, we're going to rapidly iterate and we're just going to try it, expect failure, and learn from it, and then make the changes, make the next attempt better. And, eventually we're going to get it right, and we're going to figure out how this thing actually works. And that's kind of the approach we've taken with these prototypes. I won't claim to do it as well as SpaceX does it, and we certainly don't do it as quickly as they do it. I mean, the speed with which they iterate is it's remarkable, honestly. They certainly have some money to fund those activities, yes. But yeah, I mean, bottom line is you can never simulate something with 100% accuracy. A simulation is never the real thing. And until you actually build something and find all the limitations in the manufacturing processes, the materials, and actually try it, you're never going to know for sure how well it works. So yeah, SpaceX is kind of rewriting the playbook. Yeah, I mean, so Elon Musk, who started SpaceX, comes from the Silicon Valley sort of way of thinking, right? I mean, he had PayPal before, he had several other software companies, and they do the same thing at Tesla, really. They're rapidly iterating and trying things, and yeah, that's really kind of the Silicon Valley mindset of technology development, and that has been very different from the traditional space business.
We're going to go to Zoom now, and we have a question from Zoom.
Hello. I just wondering if you know what kind of rocket you're going to be using to launch.
So interesting sort of element of this NASA's Commercial Lunar Payload Services program. They leave it up to the lunar lander provider to select the launch vehicle that will launch them to the moon. So NASA doesn't dictate that. That's part of their contract with the lunar lander provider. That's up to them. So in all likelihood, it will be a US launch vehicle. And these days, SpaceX is launching 95% of all spacecraft into orbit worldwide. I just heard that stat the other day, and it just sort of reinforced in my mind how much they've completely changed the game in the launch business. But there are others, and there are new vehicles being developed now. Company in the US owned by Amazon owner Jeff Bezos called Blue Origin is developing a series of launch vehicles as well. And there are others. So In all likelihood, it will be a US launch vehicle, but we won't know until much closer to launch, I guess.
Okay, we have a second question from Zoom.
Hello. The other thing I was wondering is if it's possible to describe some of the new technologies that you needed to develop to make the rover possible.
The I guess the thermal management system that we're designing for the rover to survive those extreme cold temperatures, but yet still be able to reject heat in the heat of the daytime and when the rover is operating. That's a pretty significant challenge. So yeah, there are some technologies we're applying there with some of our partners that are pretty specific. It's kind of it's almost like a thermal switch where it has to be open during the lunar daytime to let the heat out, but then you have to close it during the nighttime to keep the heat in. And so, yeah, that's a pretty significant challenge.
Cool, thanks.
Hi, I got a couple questions.
Sure.
One of them is, in terms of the heat during this lunar day.
Yeah.
Have you looked into, or can you talk about, using that heat to generate electricity, to store up for the night?
Yeah, I mean, there are technologies that allow you to do that. Problem is they're generally kind of heavy. And so in a vehicle the size of ours, that's kind of a challenge to carry that extra weight around. Yeah. Mass is not our friend on this mission. That's also a big challenge, is staying under that 35 kilogram limit that we have. It started out as 30 kilograms, by the way. And then when we said, I don't think we can do this, they found us another 5 kilograms, but it's still a challenge.
Okay. The other thing is, as far as documentation, it sounds like your design is not mature yet. Or can you talk about if your design is mature and how you keep up with the iterations and documentation?
Right. So yeah, what I didn't mention is kind of where we are in our development cycle. And so we're almost at what we call the preliminary design review. And so there are a number of kind of major reviews throughout the different at different stages of the program, where we have to document and then present and explain and defend our designs and our concept. In our case, it's to the Canadian Space Agency. NASA will be a participant in those reviews, more as an observer, because this is actually a Canadian-led mission. So the Canadian Space Agency has the kind of the ultimate design authority. Yeah, and documentation is extensive. Let me just say that. Yeah, we've been generating many dozens of documents over the last several months leading up to now, where we're just now basically ready to hold this preliminary design review. Yeah, and then as we go on, the next major one in about 18 months will be a critical design review, where we document and discuss the very fine detailed design of all the systems and yeah, lots of documents.
Hello? Hello?
Oh, you would like to think so, but
Yes, I was just curious. I have two questions. Will the rover be heading towards the Shackleton crater? I'm just curious about that one.
so the Shackleton crater is probably the best known crater feature at the South Pole region of the moon. It's a pretty large crater. I don't think I have I did have a South Pole map, but it was probably the largest crater that you saw in that view of the South Pole region. We're not going specifically, or we don't we don't think we're going specifically to the South Pole region, or sorry, to Shackleton Crater in the South Pole region. There's a pretty extensive activity that's going on to determine specifically where in the South Pole region we should go. And there's a number of criteria that are used to make that decision. First, they want it to be scientifically interesting, like high likelihood of finding frozen water. But there's engineering limitations too. So, for example, we want to make sure we have constant sunlight during the lunar day when we're there, because we need to keep the power, the battery charged on the rover. We also need to be able to see the Earth at all times. And from the South Pole, that's kind of difficult, because just like the sun is at a glancing angle, only a couple degrees above the horizon, so is the Earth. And so to be able to communicate with Earth, you have to have a line of sight to the Earth. And so we can't go somewhere like a deep crater, like Shackleton, for example, because the crater rim would block our view to the Earth.
It's just, I know there's frozen water in the bottom of it.
Yes,
Not been,
Yeah.
hasn't seen the day of.
That's right.
sunlight.
that's one of those permanently shadowed regions
Yeah,
that,
that's why I
that
was-
scientists would love to go to,
Yeah.
but it's
that's-
kind of difficult.
Okay, my second question is, there's another, you mentioned a number of partners that are involved in this project.
Yeah.
And I wrote a paper on Moon Express with Bob Richards.
Oh, yeah, yeah.
And Naveen Jain and like Polly is the other feather.
Okay.
They were trying to compete for the Lunar X prize.
X Prize, yeah.
Right? They didn't make it. Well, nobody made it in 2018. And so I've often wondered how Moon Express has progressed. So do they have any influence on this design at all? Are you, because I know that they design rovers and they are looking for payload customers as
Right.
well.
Yeah, so Moon Express is not one of our partners specifically on this mission.
Okay.
I have met Bob Richards actually in the past. In fact, I attended the International Space University, which he was one of the co-founders of way back in the mid 80s. I attended in 2005. But so yeah, I've met Bob, and I know some of the companies that were formed to compete in the Google Lunar X Prize have since kind of wound down their operations just for lack of funding, among other things. I can't speak specifically about Moon Express because I can't recall off the top of my head what their current status is, but yeah, they had been developing lunar landers. I know they were originally hoping to be one of these eclipse providers. But
So
yeah, not
Fast
too sure.
forward from 2018, now we're in 2024, and I just wondered
Yeah.
what progress that they've made, or if they've
Yeah.
had any input onto this kind of project.
Yeah, not on ours specifically.
Okay, thank you.
You're welcome.
So I know that there are lots of other hands up in the room and lots of questions. However, our time at this point in time is up. I know, Perry, you're going to stay for a bit. So I know there are a number of people who haven't had their questions answered. I do realize that, and hopefully you'll stay and people can approach you to ask. Now, when I met you in the summer, you mentioned to me that it might be possible to tour the sandbox. Is that still an option?
We have had some groups visit us to take a look at our simulated lunar terrain and to even have a chance to remotely pilot some of those early rover prototypes that we talked about. So yeah, I think we could probably arrange something.
So
There
there
would
might-
be
There might be a couple people in the room who might really want to pilot a
Yeah.
Rover.
Yeah, well, we might be able to figure something out.
Just a show of hands of those who might be interested to go and pilot a lunar rover. All right, you and I should talk.
Sure.
Perry, I want to thank you so much for coming to meet with us in person tonight. Your talk is it's been fascinating. It has sparked the imagination of, I think, everybody in this room, this idea of building the rover and going to the moon. I know when it does launch, everybody here is going to be following its every footstep from the launch pad to its landing and wishing it the best success. And the same for you and the team that you're working with to create this. So thank you so much for coming tonight and sharing this with us.
Thanks very much for having me.
We are going to take a 10-minute quick break to stretch your legs, chat with Perry, visit the bathroom, step outside where it's cooler and hopefully not raining, and we'll see you back in 10. All right, everybody, our 10 minutes is up. I know that there's lots of questions still. It's yours. It is not mine.
That's all I want to know. Is there a name for it? Do you know?
There isn't at this point in time.
Is there a name?
Yes, yes, I believe so. Yes, yes. But
Yeah,
we,
I'm going on a field trip, so.
yeah, yeah. I know everybody in the room wants to go drive the Rover. All right, Mr. Govro, I'm sorry. He's ignoring me. I'm just going to get started anyway. I know, I feel really bad, but I'm going to ignore them and I'm going to go on. All right. So welcome back, everybody. I'm really glad that Perry has been such a big hit tonight and that there have been so many people who want to speak to him and ask such awesome questions. So let's move on to our door prizes tonight. We have 3 books. The first one is called The Sun's Heartbeat and Other Stories from the Life of the Star That Powers Our Planet. It's by Bob Berman, and it's an entertaining biography of the sun from its stellar birth to its spectacular future death. And it offers a robust narrative of how the sun has shaped humanity and our understanding of the universe. An oldie, but a goodie. This is Comet by Carl Sagan, and I kind of picked this because I saw the comet that's out right now the other night. The authors explore the origin, nature, and future of comets. They show how comets have spurred some of the greatest discoveries in the history of science and raise interesting questions about these visitors from the interstellar dark. And finally, for those of you who are looking for observing targets, this is a catalog of stars for astronomers by Richard de Bon-Smith. It gives the characteristics of over 2,000 stars to a brightness of 5.2 visual magnitude. And the stars are listed by constellation to make the catalog very easy to use. And I looked through it and it is very easy to use. So tonight we're going to have our guest pick the first ticket. There are blue ones and yellow ones. Pick a good one. There are bad ones. It's a bad one. It's ripped. It's a yellow ticket. Last 3 numbers, 944. Come on up, Barry. All right, you pick the next one. You pick the next one.
Another yellow one.
It is a yellow one. What's the number?
945.
945. Debbie, is that you? Come on up and pick. Excellent. Pick whichever one you want since you were the first pick. And you get to pick the last one.
It is blue. It is a blue ticket under the blue. Last three numbers, 550. Douglas, I'll just take it for you. It might be back next week. All right. Of course it won't work. Thomas, how'd you fix this the last time? This has never done this before. You're gonna have to teach me how to fix this. I'll talk, you can fix. Okay. I'll let him fix it and I'll talk. So Matthew got a reprieve this month from doing the sky this month because we had, thank you. You sure it'll work? Okay, oh, excellent. You're gonna have to teach me how to do it afterwards. Because he's been solar eclipse chasing, I lost my train of thought, as have had a number of us here in the room. So we're gonna not take an awful lot of time, but I have some people who just want to share very, very briefly what they had. We also have some people's pictures to show you. So Paul, do you want to share? Whoa, thank you. Yeah, thank you. You want to share briefly what your eclipse experience? We'll give you the microphone. Just a quick synopsis.
Very quickly, never approach this lady when she says, come to the back of the room and sign up. I went back to get a name tag and she said, Paul, I'm putting your name down. It's not like I was in church. I am, you're right. So my experience was I canvassed houses down on lake, the shoreline of Lake Erie in Selkirk area back in February. And I just started knocking on doors. And I said, can I use your front yard or your lake frontage just for a eclipse party, just my family? Most of them said no. I said, I have 2 telescopes so you can look through them, and they said no. Then I found a gentleman who just by chance knew my wife from teaching. He said, yeah, he said, this is private property here and public property there. And so Monday morning I went out to stake out my area, and he text messaged me and he says, what are you doing out there? And I told him, and he said, oh, just come use my front yard and use my driveway for parking. He says, we won't mind, and it'll be a fun day. And there's absolutely nobody, I mean, nobody in eyesight for that viewing. So we got some pretty neat pictures of the eclipse on the lake at totality. My granddaughter, who is 9 at the end, said, Daddy, when are we going to get in a jet and go see the next one? She was glued to the telescopes for all the time. So I have to foster that now. But my other granddaughter, she's a real bookworm. She was reading her book. And when totality came, she showed some interest. So that's my eclipse day, and we had a big barbecue after. But they were really interested in the science of it. Like, how can this happen? After it was all done, the question was, how does that happen, Grandpa? Right? And that made my day, because it shows they're thinking more about science than they're thinking about the right? Yeah. So that's my story. Give you back to our Sue.
Don't come to me at the back of the room looking for a name tag. Thanks, Paul. Doug Curry, do you want to come up and share your experience?
I heard it here. They advertised for some, that for the Rask Hamilton meeting, and part of trying to coordinate the meetings more. So I did. I didn't fully realize, but it was. I did go up to the meeting. I got in contact with the leader of the Victor Abraham, and I went up there and volunteered a bit and giving out glasses. And, you know, it was at Lime Ridge Mall parking lot. And there was about 400 to, you know, people at the beginning of the eclipse. And I met some people I didn't expect to meet there that I knew from before. So I was spending quite a bit of time with them. And but one of the things I don't know if you've seen this before. This is some of them. They're giving these out too, that you can go put it over your glasses. For, you know, they have the filters at the top, and then they had about half of these and half the wrap around type of glasses that they're giving out. But well, I never saw a solar eclipse before, and total eclipse, so I did see it. So I, you know, I was using that for the process or whatever, and I used the filter glasses for the you know, when it wasn't total, and then I took it off. But I was glad to see the you know, it did clear with the totality. It was clear then, and it was the first time in my life I saw that with my own eyes, the corona. So I was quite happy about that, and they let me give a small talk about the moon afterwards that I prepared. So
Oh, that's awesome, Doug. Thank you. Jim, I'll come to you.
Okay. Hi, yeah, Celia and I and Lorraine, we all were out at Bimbrook. We sat up on the fishing dock down by the lake. Had a great time, little picnic out there as well. My photographs didn't turn out as well as I'd hoped, but my focus was bad because of the cloud cover. But I just set it up to run, and I didn't care. I just wanted to enjoy the eclipse itself. It was phenomenal. We had clear skies for most of the partial phases, and a beautiful big sucker hole during totality, and just had a wonderful experience. So that's brief enough. There you go.
Thanks, Jim. Gary, where are you? There you are. You want to come up here? Do you want me to come to you? I'll meet you halfway.
Yeah, the day didn't start off very auspiciously. In fact, it looked absolutely hopeless from Hamilton. I'd been invited out to Washweekend to view it. And I was going to just pack it in. My sister said, like, why didn't you go anyway? You don't know what it's going to be like 20 miles from here. So I packed up my 70mm apochromatic with a white filter. Drew out there and got there about what time is it? 1:30. Still wall-to-wall cloud in every direction. Didn't look good at all. And then in the west, and a little bit overhead too, a little sliver of blue opened up. And I thought, okay, I'm going to stick around for this. I set up the scope, and by about I'd say 1:45, 1:30, pretty much a blue sky, beautiful blue sky. And I had people look through the scope of the white light filter, and there were some tiny sunspots. And and people had never seen a sunspot through a telescope. They thought that was amazing. There were about, I probably had between 20, 25 people look through the scope and ask me about the club and about the scope. And so essentially I saw the whole, from the time it was covered, about maybe a 10% covered the moon till totality, which was absolutely spectacular. And I had a lady say, look at that big orange flame down the 7 o'clock position. I know I've seen partial eclipses before, probably as a kid, like about 70 years ago. And I know I've never seen a total eclipse before, because I would have definitely remembered it. So it turned out to be a terrific day. And I also got interviewed by a very nice young lady reporter for the Six Nations newspaper that they put out. So I'll have to try to get a copy of that. And so all in all, it was turned out to be a fantastic day from when it looked like I wasn't going to see anything. Thank you.
Awesome. Thanks, Gary. John, do you want to come up and share?
Okay, so first of all, I'm going to say how happy I am to be in a room full of people that have now experienced a total solar eclipse. This is something, right? This is a wonderful, amazing thing that we all have shared in various locations. And I can't tell you how happy I am that for those that had blue skies and those that had cloud, that cleared enough to see it through the cloud. That makes me so happy. And I'm so happy to be part of a great club that gave away like over 2,000 eclipse glasses for free, did so many outreach events and reached so many people prior to this and encouraged so much enthusiasm. What an awesome group. You all deserved this great solar eclipse. Okay, so here's a quick story.
Sorry.
Hey, that wasn't my story.
All right, he's done. He's done. No.
You remember a few years ago, we had that beautiful sunrise partial eclipse. And I dragged my wife down to the lake to see this. And she's like, why am I going down to the lake in the morning like this? It's like, trust me, it'll be great. And she didn't trust me. But after she saw the event, she said, that was really fantastic. I really enjoyed it. And then in preparation for this, when I was encouraging her to, it's like, no, we're driving, like we're prepared to drive halfway across this province to see this, to find good weather. She thought back to that event and she said, okay, I'm up for it. I will do it. Because she was thinking back to that partial event. We had beautiful blue skies, a great experience. It was stunning, just like so many of you had. And afterwards, she turned to me and the first thing she said was, partials aren't going to cut it for me anymore. So, okay, that's my story.
Thanks, John. Rhonda. This is Rhonda Edmundson, Perry's wife, and she has a great eclipse story.
I convinced my principal not to close school. We were in a private school. And I took my science club, 17 students, grades 5 to 8, with a lot of parents. We had over 9 parents, to Dunnville, Ontario. Does everyone know where that is?
Yeah.
Was anyone there that day? Okay, you would have heard the chants. Who was there? So you would have heard maybe you heard our chants of totality, totality. The kids loved it. I don't think there was anything I could do or say to prepare them enough for the mathematical lining up of the earth, the moon, and the sun. But hopefully I created some more astronomers, and I also want to echo the thank you for the astronomy clubs all over North America and yourselves who gave out glasses, because our school wouldn't we got some of them from you, and Let's Talk Science. So all the groups that did that, thank you from the bottom of my heart, because that made my job a lot easier. And we didn't have to make too many pinhole viewers.
Thanks, Rhonda. Matthew, you're last, but not least. I'll share this with you.
Okay, so we will try and keep it as short as possible, but it's not quite as short as the others. We left on the 4 of us, Janice and Sue and Doug, and I left on March 29th.
Just move over. I'm in the light of the thing. I can't see. Thank you.
Anyway, so we left March 29th. The idea was to drive to Waco, Texas, and camp for 4 days, see the eclipse, and bomb back in time for the meeting. with stops along the way. So the first night we got to Dayton, we saw the Wright Brothers graveyard. The next day we drove to Nashville. We spent 3 nights there. We saw the Country Music Hall of Fame. We went on the Natchez Trace. We saw the Parthenon. Yes, there is one there, and it's full scale. It's really awesome. Then we got in the car. We drove to Memphis with a stop in Brownsville along the way to see the Tina Turner Museum. Memphis, we went to, the Bass Pro Shop, which is an 8-story tall pyramid, which was just phenomenal. And then we decided that Waco was not so good because
it was covered with cloud and it was going to get about 40 to 50 millimeters of rain right when we'd be packing up the tents and putting them back in the truck. So the 4 of us decided to
turn around. So we came back home to our place. Sue and Doug stayed over. And then we had to make a decision. Do we stay here or go? Sue's family has a farm in Cornwall. So we got in the car and drove to Cornwall. We're supposed to have the best weather along the whole path. We got there and the next day.
I call my mother from Memphis. Hi, Mom. She goes, oh, where are you? I'm in Memphis. And she goes, oh, what's it like? Blah, blah. I said, would you be okay if some friends came to the farm with me? And she's like, how many? And I said, well, just a couple. And she goes, for what? The eclipse, Mom, the eclipse. My mom is 85. And she's like, oh, the more the merrier. If they all want to come, they all can come. And I'm like, don't say that, Mom. Don't say that. So yes, so we went to the farm. Another 6.5, 7-hour drive from Brantford.
So we got to the farm. Weather reports are awesome. The next day it was, instead of the best place you could be, it was the worst place you could be along the whole path. So we said, okay, we're going to take today. We're going to practice all our setup, do everything all over again, and the truck was packed with a lot of stuff. But anyways, we unpacked it, set up, did our thing, put it all back. Next morning, we got back in the truck and we drove to the Eastern Townships to somewhere just south of Sherbrooke. And we set up in a little village there in a park, Farnham.
Yeah.
And there was about 200 people there. And that's where we experienced totality and all that other stuff. And what else?
And then we collapsed. So in total, we are 100 kilometers shy of doing 5,000 kilometers eclipse chasing.
We had beautiful blue skies, a couple hundred people. We had our H-alpha scope. We had a white light scope. We had about 40 people come back multiple times, look through the scopes all the way through the partial phases.
And we explained astronomy in English, French, and Spanish. Yeah,
very little Spanish, but a little. But anyway, so that was our experience. It was phenomenal, and yeah, how far is it in Sabine? We know we can't drive the truck, but other than that, I think we're good. Maybe we'll go.
And we're all still friends after all of that. So a number of you have been sending photos to Matthew. And before I show you the photos, there's a piece of information that Joanne shared with me, Joanne Salchi, who's been our contact with, of course, now it won't go again. Come on. Thomas, I'm going to put you on speed dial. Joanne shared some information about what to do with eclipse glasses after the eclipse. And these are the places where you can donate them. All of them will go to Astronomers Without Borders to be used in places where solar eclipses occur, but they don't have access or means to provide solar eclipse glasses to the populations there. So Hamilton Public Libraries, Grimsby, Oakville, McMaster, or you can send them to the Hamilton Center of the RESC at that address. So please don't throw them out and put them in the landfill. If you can donate them, please send them someplace where they can be donated. So with that, John, while I'm switching gears here for the video, can you come up and explain your eclipse picture? Because I think you have a very unusual picture that may not be, yes, you, yes, that you might need to explain.
Matthew, I'm still looking forward to seeing all of these beautiful eclipse pictures, but Matthew included one of mine that's a landscape, and it's something that that many of us had a chance to experience. And you can see the shadow of the moon in the sky. You can see, right? You can see the shadow there. You can see the shadow of a truck on the dirt road that we were standing on. So, you know, it's just after totality. So the sun is shining. You can see clear how, you know, how clear the shadow is. And if you look down the road, you can also see the headlights of a truck. So you know how dark it is. And it's just one of the, as many of you experienced, weirdest things to be standing in direct sunlight, and yet it still be dark enough that streetlights and car headlights were necessary, even with direct sunlight out. And then, as Matt wanted me to point out, that you can actually see the you can see in the sky, you can see it's not facing towards the eclipse, it's facing away as the shadow is moving away. So as it rolls by, that's why there's just this weird country road picture in the sequence.
Okay, now. Okay, so the first video that we're going to see is from Dan Copeland. Oh, no. What do you mean, oh, no?
Okay, this was a group of us that got up at 4 in the morning, Chris and I anyways, and drove all the way out to Rondeau Provincial Park. And as you can see here, we're set up in the park, but there wasn't as many people as we thought they were, because they sold out and they said no other people can come out. And this is our neighbor. He was there before us, so I had included him. He's from Kitchener. And then there's the equipment that we used and trying to get some idea what they were looking at. That's my Coronado. Then there is the dwarf in the back of that one. And there's Chris with his Sea Star, and Chris, I think there's 3 Chris's there, 4 Chris's. Then we got Robert. He doesn't like his picture. You see him nodding his head. He doesn't like his picture taken. Then there's Les. He's set up. Then we come along and we've got, who do we got back here now? There's Terry, and there's Chris, and Chris again, and his son. Actually, I think there's some audio on this or not?
Yeah. They're just single.
They're single. And, but you see the promise.
Yeah, just because the promises are praying, that's what you have to do a double tap. You can see these.
That's Ann.
That's Ann, right? Yeah. Trying to see what he's saying. But we had a good view, but you see the sky started to cloud up, high level clouds. It was perfectly blue about half an hour before this time. And these some other people that were there. Yeah. And that's it.
Thanks, Dan. Okay.
So you still have stop sharing.
Go to the other one. Can we turn out the lights, the back? It's a prominence that's coming off the sun. It's like what's coming up from the top of a sunspot. Jeez.
That's after the eclipse.
Oh. Yeah. Oh.
Yeah, I know. Come out. Oh. Look Oh, Bailey. Hey, Jupiter. I'm in Toronto. That's better. That's better. 20 seconds. 20 seconds. Oh, yeah? Till glasses back on. 20 seconds. Yeah. Diamond ring's coming. Diamond ring's coming.
Can we get the lights back or just a bit of the lights? Thanks. Thanks, Joanne. So that brings us to the end of our meeting. We've gone a little bit over time tonight, but we've had lots of time to chat about lunar rovers and all of the wonderful eclipse chasing that everybody did. It was a once in a lifetime event right over our heads, and it was just amazing. So thank you to everybody who shared pictures with Matthew. It's something that none of us who experienced it will soon forget. So the next time we are here on Friday, May the 12th, Dr. Chris Gillings will be our speaker that night. And until then, safe travels and clear skies, everybody.